I was working in the US Virgin Islands doing hurricane damage assessment and recovery. During my time there, I evaluated a whole lot of buildings, and I kind of saw the problems with the traditional assessment process. People went out to site, they recorded things by hand, they took pictures, they came back to the office, they labeled things, then they'd realize they'd forget things, and they'd go back on site.
The way that building inspections are done right now is it's very difficult for engineers to get out to a building, it's difficult for them to get on the roof, it's difficult for them to perform the inspection itself, and then it becomes difficult for them to get the inspection report out at the end. They generally take weeks in case they have to come back and rescan the building. And for underserved communities, what that means is that their buildings are not inspected to the degree that they should be.
The church traditionally has been sort of the center of a community. And when we talk about sustainability, we always think environmental issues, but sustainability really goes down to the neighborhood level, down to the local level. So it's about sustaining the neighborhood. That building represents not just a physical structure, but it really represents something in neighborhoods, whether it's people coming from different countries, going to the church because they need that community. And so having a building that's poorly maintained affects everyone, not just the people who work there, but the entire community around it.
Really great things is just knowing that for the Archdiocese, we can be out there and improving their buildings and improving their facilities. They don't have a large working budget, and so for them to bring on engineers would be a very expensive undertaking. And it's just nice being able to know that we can help out these organizations that do so much good in their communities.
We wanted to resolve these issues by introducing a system that's more efficient, is more accurate, and consumes less time. That's why we integrated robotics and AI to produce a system that produces reports in an automated manner.
In this project, we are innovating and testing the idea of combining the state-of-the-art robotics technology and also the AI technology to help the roof inspection. I believe this is the future.
Because of time constraints and budget constraints, it was difficult for us to achieve the accuracy we wanted with our system. In the start, we didn't have much data for our ground penetrating radar to train our AI. And so in the start, we used a camera, and then we moved to a LiDAR for more accuracy. We were able to achieve good results that match industry standards as well.
We just want to validate our tech, improve it, use it in real-world scenarios, and advance our technology as far as possible with this awesome opportunity that we've been given.
The key parts of that tech is that it's transportable up to a roof. It has all the sensors that we need on it, so it's able to collect a large amount of data from the roof.
Because rooftops are of different kinds and have different materials, you cannot have one sensor to detect all of them. The traditional sensors are not capable of doing that. The ground penetrating radar we use and the AI we have trained for it basically overcomes that fact of different kind of rooftop materials and different environments.
Through this project, we were able to secure pilots with the Archdiocese of New York and the City of New York. We got 200 buildings that we're able to scan, which has helped our technology improve tremendously.
Being able to see early on where those issues are can save us, we're talking hundreds of thousands of dollars. On being able to see where the issues are in the envelope. Again, all of those things being affected by the elements, being able to identify that early on helps us to target it and save it. When we were able to have our meetings with the parishes and go over the reports, some of it obviously is more detailed than the pastor, but when we're talking to the construction, they were floored by it. The detail on being able to see where the issues are on a particular roof, where the issues are in the building. We don't have a lot of money, so we really need to be able to hone in and focus on those areas that we can solve right now. So those reports were awesome. With a traditional roof inspection, you're going to have the contractor come out there and tell you what needs to be repaired. The difference I noticed with having a robotic go over the roof, there are issues that they may not address. Having an unbiased report as opposed to getting the report from the contractor, because you might have someone come out and say, oh, you need to rip up the entire roof. Well, maybe we don't need to rip up the entire roof. And that's what we want to be informed with.
The most fulfilling part about working on this project is to directly see and feel the impact of our research to the society, to our partners.
I think that the future plans for this company are limitless. One of the things that we're working on right now is a wall climbing bot that uses the base technology of our roof robot and basically applies that on a vertical facade. Something like that has huge implications for New York City. And that's just one application. We could use this in construction sites. We could use this to collect visual data, present that sort of data to construction clients so that they can present their downstream clients with better visualizations of how the project is shaping up. We could use this for measuring things out. A lot of this stuff has actually been proven that we already do. So the possibilities are huge.